Suppose that Alice wants to broadcast a message to the community. The message reads, "Please send 50 God Bitcoin to Bill, signed me, Alice." Meanwhile, Bob is pretending to be Alice. He sends a message that says, "Please send those same 50 God Bitcoin to me, Bob, signed Alice." The community needs a way to verify the message. Which one of those is authentic? In the past, we've done that with physical signatures. We all know their weaknesses. They don't change, and they can easily be forged. We need digital signatures that can easily be verified, that can't be forged, and change with every message. So let's look at this from the standpoint of numbers. We have to make a few assumptions. All messages can be translated into numbers, and the community can do some math, but there's some math that they can't. The real digital signature math is far too complex to explain in one simple video. Our goal is just to get the intuition. So let's assume that Alice has a signing key or a private key, which is 3 times a message. She broadcasts to the whole community. The message is equal to 4. Everyone in the community knows exactly what that means. They see the signed message of 12. Only Alice can generate that because she knows the signing key is 3 times a message. Her public identity is not Alice, but it's public key 21, and there's a verification formula. Again, look at the assumptions we're making here. We're assuming that the community can't solve for signed message. They know M is 4. They know public key PK there is 21. They can't do the algebra because they're not smart enough to find out what SM signed message means. However, they're smart enough to solve it. So they say 4 times 21 plus 24 divided by 12 is equal to 9. Verify that that is correct. That's the real message. But Bob has stolen Alice's signature. That would be a problem if the signature didn't change. So now Bob, not Alice, sends a message that says, "Please send 50 God Bitcoin to Bob." Again, this is translated into numbers. So the community sees the message is equal to 5. They know exactly what that means. They know that means please send 50 God Bitcoin to Bob. They see the signature of 12. They see that sent from public key 21 with the same verification formula. They do the math, plug in the numbers, 5 times 21 plus 12, all divided by 12 is not equal to 9. They say, no, this is not a valid signature. This is not a transaction that we'll approve. So what digital signatures do is they rely on one-way functions. Again, it's something that I can verify, but I can't solve for. So the algebraic formula that we saw before, no one could solve for the SM, the signed message. But they were all smart enough to plug the numbers in and verify that that verification formula was true, that that did equal. The only person who can come up with the signed message is the one with the signing key. That's only known to the real person. There's a mathematical relationship between the sign key and the public key. Again, in real life, it's much too difficult to explain in one simple video. The math is very complex, but that's the intuition. It's a one-way function. You can't solve it, but once you see the answer, you can verify that the answer is correct, or you can show that the answer is incorrect. Correct answers, accept the message. Incorrect answers, don't accept the message.